We have this problem. A spherical region carries a uniform charge per unit volume ρ. Let R be the vector from the center of the sphere to a general point P within the sphere. The first question says, show that the electric field at P is given by electric field is equal to ρ times R over 3 times epsilon 0. From this problem, we have to remember that phi from the electric flux is equal to electric field times area, and this is the same as the charge inside the Gaussian surface over epsilon 0. So we have an area from the sphere that is equal to 4 times pi times r squared. And we can substitute this in this formula. So we have electric field times 4 times pi times r squared. It's equal to ρ, the volume of the sphere, times epsilon 0. And this, it's equal to ρ times 4 pi r cubed over 3 times epsilon 0. So electric field is equal to ρ times 4 pi r cubed over 3 times epsilon 0 times 4 pi r squared. And we can cancellate this with this, this with this, and the square with the cube. So we get that electric field is equal ρ times r over 3 times epsilon 0. Okay. If you don't understand what happened here to here, this is a clear form electric field. It's electric field times 4 pi r squared equal to ρ 4 pi, I'll erase it, r cubed over 3 times epsilon 0. This is multiplying electric field, so it will be dividing electric field, and the rest is this. Now we have this second question. A spherical cavity is created in the above a sphere as shows in the draw. Using superposition concepts, show that the electric field at all points within the cavity is equal to electric field is equal to ρ times area over 3 times epsilon 0, uniform field, where A is a vector connecting the center of the sphere between the center of the cavity. Note that both these results are independent of radius of the sphere and the cavity. For this question, from this problem, we have to remember the first electric field that we obtained in the last problem. And we know that the total electric field is equal to the sum of all the electric fields. So, in this case, we know that the first electric field is this electric field plus a second electric field of the little cavity. So we can know that, and we have to get 0. So we can obtain that electric field 1 is equal to minus electric field 2. And we know that radius is equal to radius A from the cavity plus delta R. This is because we have this cavity of radius A and this space from radius R, and this part from the center of the cavity to the top of the sphere is delta R. Now, substituting values, we know that total electric field is equal to rho times R over 3 times epsilon 0 minus rho over 3 times epsilon 0. But rho is not multiplying R, is multiplying delta R. And we can simplify this like rho times R minus delta R over 3 times epsilon 0. And this expression is equal to A equal to R minus delta R. So we can say that the electric field is equal to rho times A over 3 times epsilon 0.